gas transport of gases. The slide here shows how oxygen is being transported from the atmosphere to the tissues and how carbon dioxide is transported from the tissues back into the atmosphere. Alright, so everything we're talking about gas transport is a mechanism of how oxygen gets to the tissues for it to be utilized and how carbon dioxide is transported out of the lungs to the external environment. Okay? So generally, oxygen is transported from, if you look at the diagram, oxygen moves from the lungs, the alveoli of the lungs, into the blood. Okay? And then from the blood, it enters the tissues. It is at this point, at tissue level, that the oxygen is utilized. Alright? Conversely, carbon dioxide in the tissue enters the blood, and from there it is transported to the alveoli of the lungs, and from there it goes to the atmosphere. Okay? So all in all, the blood transports not just oxygen, but also carbon dioxide. Some of you don't know that the blood is also the primary vehicle that carries carbon dioxide. Okay? But we shall see in this class how both oxygen and carbon dioxide are transported by the blood. So we want to begin the lecture by looking at oxygen transport, or transport of oxygen. So when we are done with transport of oxygen, we will now look at carbon dioxide transport. So transport of oxygen. Oxygen is transported. This slide is not clear in my eye. Can you see from the back? Those of you behind. Those of you behind, can you see? Huh? Okay. Oxygen is transported in the human body in two ways. Oxygen is transported in the human body in two ways. Number A is by dissolution in plasma. I say number A, by dissolving in plasma. Number B is by binding to hemoglobin. So there are two ways by which oxygen is transported in the body. One, by dissolving in plasma, and two, by binding to hemoglobin. Okay? Only a negligible amount of oxygen, about 1.5%, is transported by dissolving in plasma, which is the fluid component of the blood. I said only 1.5% of oxygen is transported in the human body by dissolving in plasma. And then a greater percentage of oxygen is transported in the human body by binding to hemoglobin. Yes? I can't hear you. I think we have a second mic. Can you speak now? Does it have a range? Yes. In physiology, we need ranges. We always have ranges. Okay? So, but we are talking of a percentage now. I'm not hearing you. The book you read. 3%. 3% against what? Is it blood or plasma? Plasma. 3%, then 97% binds to hemoglobin. Yeah. That is why I said, look, there are ranges. Sit down. Okay? In fact, some authorities will also tell you that only 1% dissolves in plasma and 99% binds with hemoglobin. Look, you don't get confused by all of these things you read. Figures or values. There are ranges, physiological ranges, and that is why anytime I teach, I draw your attention to that, because this same question was asked by those of the superiors who just wrote MBBS exam. And they said, sir, what the values you gave are different from the ones in the textbook. I asked them, what textbook did you read? Essentials of Physiology. What is the figure there? The person stated. What figure did I give? The person stated. I said, what is the difference? You are saying, textbook you read, 3% dissolved in plasma, and 97% is being binds with what? Hemoglobin. And here you are saying 1.5% against 98.5%. In other textbooks, you might see 1% dissolves in plasma, and 99% binds with what? Hemoglobin. All these things are correct. What we are trying to communicate to you is simple. Is that a greater amount of percentage of oxygen is transported in humans by binding with hemoglobin. Only small amount of that dissolves in plasma and is transported in that form. It's a simple message. So why are you so disturbed? Okay, you want to know which one to write in the exam? Whether to write 1.5% or 98.5%. You'll be making a big mistake. The people teaching you are not, well, they are not that smart. When you write an exam, you mustn't give us the exact figures or values we are giving you. Okay? You must not even write it in the same sentence with your own tenses or language. The thing is, if you are writing the correct thing, the lecturer knows you are giving your score. But you must know that in physiology, there is no fixed value. You might take samples from everybody here to test anything, and you won't get the exact figure. If, for example, you want to check the habits of everybody in this class, you will not get one single figure for everybody. And that is where physiological ranges come. Okay, if this person was a normal habit, yes? 72 beats. I mean, you are wrong. You are wrong. 60 to 100 BPM. Because, look, if you check the habit of everybody in this class, you will not get 72 for everybody. Some will be 60, some will be 65, some will be 98. So, but the question is, does this person's heartbeat falls within the normal physiological range? Yes. So the person is normal. And that is what you are going to have patients in the future. And you will send them to the lab. Maybe you are doing urinalysis. You send someone go and do a urine test. Break your mind. The lab scientists will not give you exact number. Okay? In fact, if you check the report, you will see that for urinalysis, what are the constituents in the urine? If, for example, sodium, okay, the range is this to this. What is the person's sodium content in the urine? You say is this. Does it fall within normal range? Yes. Is it abnormal? That is where you begin to say, okay, there's a problem. Is it outside the normal range? Okay. So please, you are all correct, okay? Moving forward. Moving forward. Okay, the slide here shows you the difference between oxygen dissolved in plasma and oxygen that is bound to hemoglobin. Like I said, only 1.5% dissolved in plasma and 98% binds with hemoglobin. Okay, there are about 0.3 million. 0.3 million of oxygen dissolved in 100 ml of blood. 0.3 million. Okay? 19.5 mils of oxygen, there are about 19.5 mils of oxygen in 100 mils of blood. For the oxygen that is, bound to hemoglobin. Alright? But the thing is, the amount of oxygen that dissolves in plasma is not adequate to satisfy the body needs or the tissue needs. Because this amount is very small. Okay? But oxygen that is transported by binding with hemoglobin can actually satisfy all the tissue needs. Okay? Oxygen combined to hemoglobin. Of course, when we did blood physiology, I thought we discussed the structure of hemoglobin. Okay? By now, you should know that hemoglobin has 4 subunits. Alright? The structure of hemoglobin. You should know that. These are things you have done in physiology. You have also done it in biochemistry. So if at this point you don't know the structure of hemoglobin, it's better you begin to check the basket now. Alright? I'm just giving you a rough sketch of what the hemoglobin molecule looks like. Okay. Let's say this is the hemoglobin molecule. Each subunit will have alpha and beta chains. That's no news. Okay? But the thing is that each hemoglobin molecule can carry up to 4 oxygen molecules. Alright? So oxygen binds here. Oxygen binds here. Oxygen binds here. And another one binds here. So if we want to do that using a chemical reaction, we will say Hb plus 1 molecule of oxygen. What would that give you? What would that give you? Hb O2. Alright? HbO2. If HbO2 reacts with another molecule of oxygen, what will that give you? Sorry, this should be oxygen. Yes? HbO2 plus O2. How will it give you? Jesus Christ. What will that give you? HbO2 plus O2 will give you what? Hb2O2. Hb2O2. Yes? Yes? Hb bracket O2, close the bracket, then what will be outside the bracket? Huh? 2. Another 2. What's the name of that? Huh? People are not serious. This will give you Hb. HbO4. HbO4. I am busy speaking grammar here. If HbO4 reacts with another molecule of oxygen, what will it give you? Huh? Yes? Don't rush before you feel it. What will it give you? HbO4 plus O2. What will it give you? Huh? HbO6. Okay. It will give you HbO6. Alright. Now, when oxygen combines with hemoglobin, oxygenated hemoglobin is formed. And it is in this form that the majority of oxygen in the body is transported to meet the tissue needs. But remember that when oxygen binds with hemoglobin, your tissue will suffer from hypoxia. Are you aware of that? The more oxygen binds with hemoglobin, your tissue suffers from hypoxia. True or false? Huh? It depends. Did you say it depends? Why did you say it depends?
Is a physical change, so and because it's physical change, it doesn't really have a very strong contact, so it should also get the oxygen. Or maybe in a situation whereby, let's say, for some physiological reason or biological reason, it gets difficult to be able to describe it.
I don't understand anything you just said. Confusing. What is it? Alright. Look. The blood is flowing. Alright? And in that blood there is hemoglobin. Okay? And as that blood is flowing, the hemoglobin takes oxygen. Oxygen together with hemoglobin gets to your body cells, tissues, and organ system. There is a need for that oxygen to be released to the tissues. Otherwise, if that oxygen is not released, then the tissues will lack the oxygen. I don't know whether you are following. So, there are certain things that goes on in the body that cause this oxygen that is being carried by hemoglobin to be released to supply your body cells, tissues, and organ systems. Because if the oxygen is not released and it continues to bind with hemoglobin, then the cells and tissues will lack oxygen. Did you get it? I don't think. Don't worry, we shall get to that under the oxygen hemoglobin distribution curve. Okay? So going forward, just quickly, we need to look at some things, beginning with oxygen content in the blood. Very quickly, please. The one we use this class. Oxygen content of the blood. I'm going to define some of these terms very quickly. The oxygen content of the blood is defined as the total amount of oxygen carried by the blood. Oxygen content of the blood is defined as a total amount of oxygen carried by the blood. Mathematically, the oxygen content of the blood is equal to oxygen dissolved in plasma plus oxygen combined with hemoglobin. Mathematically, oxygen content of the blood is equal to oxygen dissolved in plasma plus oxygen combined with hemoglobin. Remember that in every 100 ml of blood, there is 0.3 mils of oxygen. That is in the plasma. And then the one combined with oxygen is 19.5 mil. If you go back to the previous slide, you see the explanation there. Therefore, if you take the sum of that, 0.3 plus 19.5 mils of oxygen, the oxygen content of the blood is therefore said to be 9.8 mils per every 100 ml of blood. The next one is the oxygen carrying capacity of the blood. Oxygen carrying capacity of the blood. This is defined as the maximum amount of oxygen that can be carried by hemoglobin. The oxygen carrying capacity of the blood is defined as the maximum amount of oxygen that can be carried by hemoglobin. Are you following? Okay. Recall that each gram of hemoglobin, when fully saturated, carries about 1.34 mils of oxygen. Each gram of hemoglobin, when it is fully saturated, carries 1.3 mil of oxygen. What is the normal hemoglobin content in the blood? What is the normal hemoglobin content of the blood? 15 grams. Are you sure? In male or in female? In male. Okay. So if hemoglobin contents, if the hemoglobin content of the blood is 15 grams or 100 mils of blood, then the oxygen carrying capacity, the oxygen carrying capacity of the blood will be equal to 1.34 times 15 grams. Alright? I thought you guys got to match it. So if you solve the mathematics, you are going to get 20.1 mil of oxygen as the oxygen carrying capacity of the blood. Okay. Okay. So the next thing we need to look at is the percentage hemoglobin saturation with oxygen. The percentage hemoglobin saturation with oxygen.
Based on the calculation, we got that the oxygen carrying capacity is 50.1. We usually say that the hemoglobin carrying capacity is 20.5. In this calculation, the oxygen carrying capacity is the same as the amount of oxygen carried by the oxygen of the blood. Because 20.1 billion liters. Now in initial slide, that the oxygen carrying capacity of the blood is 19.6.
We are looking at when this hemoglobin is completely saturated. You know what saturation is? You know what is it? Completely saturated with oxygen. Alright? You don't have to be confused about that. For time's sake, maybe I'm going to talk about that. I'm going to talk about that in our next class. So please, let's speed up. I will advise you to also look at the textbook. Okay? People, when students complain that respiratory physiology has a lot of calculations and mathematics. Medical students shy away from medical statistics or mathematics. But it shouldn't be so, because even in medical practice, when you start practicing, you will solve mathematics. Some of you are not observant. So when you go to the hospital and they are giving you infusion drip, they calculate how many drops. There are times when the doctors will slow down the number of drops per minute. There are times when they will rush a patient to the hospital, the doctors will have to rush and drip on the infusion. It will be properly like that. There are times when it has to be more than, okay? So you don't need to shy away from all this medical maths. Know them. So the percentage hemoglobin saturation with oxygen is defined as the index for the extent to which hemoglobin combined with oxygen. Mathematically, it is given as oxygen bond to hemoglobin over oxygen carrying capacity of the blood times 100 over 1. So what is the oxygen carrying capacity of the blood? What is the value of the oxygen onto hemoglobin? Okay, do the calculation and write your answer down. I'm going to mark it. Okay. Unfortunately, we have to stop here. Alright? When we meet again, we are going to look at the oxygen-hemoglobin dissociation Borh and carbon dioxide transport. And if time permits, we'll look at regulation of respiration. So please, thank you for coming. Does anyone have any question quickly?